Hi, my name is Joydeep and I'm a PhD student at the Department of Electronic Systems Engineering, Indian Institute of Science. I will be presenting a short overview of our work on Tactile Internet. Tactile Internet is a vision to enable haptic interaction with a teleoperated environment over the Internet, that is, support bilateral communication of kinematic and haptic data over the Internet. An example of a tactile internet application is telesurgery, where, for example, a surgeon in Bangalore can perform surgery remotely on a patient in Delhi using surgical robots. Such applications require real-time haptic feedback to provide transparency, such as when the surgeon performs surgery in the operation theater. In a system where the end hosts communicate via a network of Ethernet switches, the packets face two types of delay. One, network delay, and two, processing delay. An example of network delay is queuing latencies at the switches, where the packets wait before being allowed to be dequeued. In a real-world setup, many end hosts share the network and continuously push non-critical best effort traffic to the network. A situation arises where the network gets congested and critical data, also called scheduled traffic, gets queued for a long time and therefore is unable to meet the application's upper bound latency. Example of processing delay of the end hosts are solving inverse kinematic equations by the robotic arm to get the target position, and calculating the haptic feedback by the haptic device. We aim to design and analyze strategies to reduce round-trip latency for such a tactile cyber-physical system by designing a low-latency network and exploring edge intelligence techniques. The first step is to implement a testbed and perform baseline measurements. The testbed setup includes a haptic device capable of haptic feedback, a teleoperated arm with a gripper mechanism, a camera, a video display, and a basic network setup connecting these devices using socket programming so that any two devices with IP addresses can communicate over the internet. Here is a short demo of our setup. A person operates the haptic device to control the teleoperated robotic arm to write a word over a LAN connection. The following graph shows a snapshot of the position difference between the end effector of the haptic device and that of the arm. Our approach towards realizing such applications, which require low latency and high reliability using tactile internet, uses the concept of time-sensitive networking, in short, TSN. In brief, it's an IEEE 802.1 standard with the goal of providing determinism on traditionally best effort Ethernet networks. TSN promises low latency and high reliability transmission. Our current work focuses on building a TSN switch. We chose Netronome Agilio SmartNIC for its reconfigurability, high performance, and flexible programming using an open source networking domain language called P4. We implement a TSN shaper called time-aware shaper that requires network metadata like timestamps, time synchronization among all the switches, and multiple queues to guarantee a bounded latency to scheduled traffic. In the figure, a host named TX2 transmits scheduled traffic to the receiver RX. Simultaneously, two other hosts are sending best effort traffic to RX. A time-aware shaper works as follows. The switch forwarding table queues the scheduled traffic in a separate queue, following which a gate control logic or gate scheduling algorithm controls the opening closing of the queue gates. The following figure shows preliminary results of the end-to-end latency of all packets at the receiver RX. The two graphs demonstrate the latency in a traditional switch on the left and with a simple implementation of a time-aware shaper on the right. In each graph, the two best effort traffic with priority 0 are on the left and the scheduled traffic with priority 1 is on the right. We are able to isolate priority flows and get a bound of 1 millisecond on the latency. Our current work focuses on offloading the entire logic from the kernel to the SmartNIC fabric to get a further reduction. Thank you.